Hello everyone, I'm Borotan Z. This time, I'm going to work on making the girl we created last time movable as a VTuber. Since the modeling is finished, we will add an armature to make the body movable. We will create the ah, ee, oo, a, o mouth shapes so she can speak, and also create expressions like smiling, being angry, or being sad. By outputting the data in VRM format, you can use it in various software that can run VTubers, such as VSeeFace. If you use Blender, you can easily create an original VTuber character in VRM. I want to show you the process from outputting VRM in Blender to animating the VTuber in VSeeFace. Using the techniques I've shown you so far, you can easily turn various characters into VTubers. So, if you are interested in VTubers, please watch until the end for reference. This channel aims to share tips and information for enjoying 3D CG creation for those who are starting 3D CG or aspiring to work in 3D CG. If you like it, please subscribe and give us a high rating. Let's get started. First, I want to install an add-on for creating VRM in Blender. Open Edit, Preferences, and Display Get Extensions. Click Extension Settings in the top right. Select Visit Extensions Platform and display the extensions homepage. Search using the search bar at the top or display VRM from within the add-ons. Click Get Add-on on the bottom right of the VRM page. Since the display changes to drag and drop onto Blender, drag and drop it onto Blender. Installation is complete when the installation starts and VRM format is displayed in Installed. The VRM tab will appear in the Tools panel. Next, we will create a Rigify facial rig for the character created in the previous video and start creating expressions. First, we will integrate the models. Since the face is grouped by the face texture, we integrate the face models into one. Since the hair uses the hair texture, we leave the hair model separate. Since the body textures are also grouped, we integrate the body into a single model. Once the models are organized, we add a Meta-Rig to create the Rigify rig. Select Human from the Add menu, Rigify Meta-Rig. Adjust the scale of the Meta-Rig to be about the same size as the character. Matching it to the height of the shoulders is recommended. In the armature properties, Viewport Display, check In Front. This makes the armature always display in front. Then switch to Edit mode to precisely determine the bone positions. You can change this position anytime later, so it's best to decide the appropriate location while converting it to a rig. To convert it to a rig, there is a Rigify section at the bottom of the Meta-Rig properties. First, press Update Face Rig. The face rig is modified. If it looks good, press Generate Rig. The rig is created. If you apply the scale of the Meta-Rig to 1, the rig will be created at the appropriate size. To make the character movable with the rig, select all the meshes, and finally select the rig. Execute automatic weights under the parent option in the object menu. By selecting the rig and switching to pose mode, you can move the character. We will use Rigify this time only for creating expressions and converting to the T-pose, T-stance. We will test if the expressions move. We also check if the arms look good when raised straight out to the side. If there seems to be a problem, return to the Meta-Rig and adjust the bones repeatedly. Since the eyes are hemispheres, if the bones are not in the correct position, the eyes will pop out when the character looks sideways. Adjust the bones to the correct position. Since polygons remained on the backsides of the shirt, pants, and shoes, we delete them. After the overall adjustments are finished, we parent them with automatic weights and proceed with fine-tuning the weights. When moving the character with the rig, there are many places where the weights are strange. To make adjustments easier, pose the character using the rig. Select the model and activate the two icons before the armature modifier, on cage and edit mode. By doing this, you can adjust the weights using the pose set by the rig. Adjust the weights using the vertex weights in the Item tab. If adjusting is difficult, painting in weight paint mode is recommended. Move the face rig around to adjust any strange weights. Also adjust the teeth and tongue. Now that preparation for creating expressions is complete, we will use the Rigify facial rig to create them. The VRM format requires creating 17 basic expression shapes. We create the neutral expression, neutral, the A, E, U, A, O mouth shapes, the blink, joy, angry face, angry, sad face, sorrow, and fun face, fun. We also prepare the face looking up, looking down, looking left, looking right, look right, blinking the left eye only, blink L, and blinking the right eye only, blink R. We create the expressions by setting keys every 10 frames on the timeline for the Rigify rig. It's good to create them while looking at your own face in a mirror, or while referring to reference materials. I will place the reference image in the background. Select the Rigify rig and switch to pose mode. Press Ctrl-A to select all the rig bones. Press the S key on the first frame to set a key. Frame 1 will be the neutral pose. Move the timeline to the 10th frame and create the A mouth shape. Once the shape is created, select all the rig bones and set a key on the 10th frame. Next, move to the 20th frame and create the eye mouth shape. Copy the key from frame 0 and paste it onto the timeline. Since it becomes the neutral shape, it makes the work easier. Create the eye mouth shape and set a key. We will create the necessary expressions in this manner. Once all expressions are finished, switch to Object Mode. Select the face model and set the timeline to frame 1. Open the menu on the right side of the armature modifier and press Save as Shape key. This registers shape keys named Basis and Armature in the Data Properties Shape Keys section. Change the name of the armature one to Neutral. Then set the timeline to 10 frames and press Save as Shape key again. Since armature is registered in the Data Properties Shape Keys, change its name to A. Continue moving the timeline and register all other shape keys in the same way. Once everything is registered, return the timeline to the beginning. Check if the shape keys are registered by setting the value of the shape key to 1. If there are no issues, the expression creation is complete. If you want to create additional expressions, add the expression on an empty frame and register the shape key. You can add as many as you want, so try making various ones. Places where the expression changes between keyframes can also be registered as shape keys. Next, we will change the armature currently parented to the character to an armature for VRM. Since we want to keep the original Rigify rig, we duplicate the collection containing the character. Hide the original collection. Name the duplicated collection VRM. Select the model parented to the Rigify rig and clear the parent relationship. Then delete the Rigify rig and the Meta-Rig. The model name has numbers, so we change that. Delete all vertex groups in the model properties. We will add the VRM armature to this model that has the shape animations. Display the VRM tab and press the Create VRM Model button. This adds an armature. Scale this armature to match the character. Apply the scale, switch to Edit mode, and determine the detailed positions. After determining the positions of all armatures, we add extra bones. Select the joint above the chest bone and extrude it using the Extrude tool. The armature is added to the chest hierarchy. By unchecking Connected in the bone properties relationships, you can move the bone position. We designate this bone to move the breast fluff/tassel and set its position. Change the name and append .l. Perform symmetry from the armature menu. An R bone is created on the opposite side. Next, we add bones for the hair. Similarly, disconnect, uncheck Connected, and place the bone at the desired movement location. Change the bone's name. Then, performing subdivide splits the bone. Set the subdivision count in the bottom left to 2. The bone is split into 3. Select the bone and perform symmetry. We add bones overall in this manner. Once the bones are added, we parent the model and the armature. Select all models, and finally select the armature. Perform automatic weights for parenting. Switch to pose mode, move the bones, and check if the deformation is correct. There are many places where the weights are strange, so we will adjust them. Select the vertices you want to adjust the weight for, open the Item tab, and adjust the vertex weight value. Set the value to 1 and press the Paste button next to it to paste the weight onto the selected vertices. We fine-tune the weights this way. Using the gradient tool in weight paint mode allows you to apply weight within the dragged area. It is recommended to apply large weights using vertex weight and then fine-tune using weight paint mode. For hair weights, hiding the hair strands other than the one you want to weight makes it easier to apply weights with the gradient tool. Once all weights are applied, select the model and apply Normalize All from the Mesh menu, Weights. Then apply Limit Total Vertex Groups from the Object menu, Cleanup, and set the limit value to 4. Next, we perform texture baking and material organization. First, we bake the diffuse and normal textures for the hair. Select the hair and move to the Shading workspace. Since the hair shader is complex, it cannot be displayed as is in the VRM format. Therefore, we want to bake and consolidate the textures so that the shader becomes simple. Although we had previously set the hair color to be changeable to red, since we are baking the color, we want to revert it to a natural brown color. Once the color is decided, copy the color to the thinner hair strands as well. Then, in the image editor next to it, create a new image for baking. Append diffuse to the name. Create a 2048 by 2040 image with alpha. And in the shader editor, add an image texture node. Select the created diffuse image. To bake, confirm that the render properties are set to cycles. The bake section is located lower down in the properties. Uncheck Bake from Multi-Res and set the bake type to diffuse. For the influence contributions, uncheck the box for whether or not light should affect it, leaving only color. Select the image texture node and press the Bake button. Once baking is finished, you can check it in the image editor. It is baked with alpha. Don't forget to save the image. To confirm, disconnect the previous node connections and connect the baked image. Connecting the alpha also confirms that the transparency is fine. Confirm that the texture coordinates are also fine. Next, we also bake the normal map. Similarly, create a texture for the normal map. Since normals do not use alpha, uncheck the alpha box. Add a node, set it to the created image, and set the color space to non-color. Set the bake type to normal and press the Bake button. The normal map has been baked, so save it. Connect it to the coordinates, add a normal map node, and connect it to the normal input. Confirm that there are no issues. Now the hair material is simple. You can also bake metallic, roughness, and others. Even if you create complex nodes, you can easily express them in games or VTuber applications. So it's good to remember this. We consolidate other materials by baking them in the same way. Once all materials are baked, we consolidate textures that can be grouped. Since it's better to combine the textures for the shirt, pants, and shoes into one, we composite them using image editing software like Krita. Normals are composited using Overlay. Roughness is composited using Screen. Return to Blender and organize the materials. Since the hair materials are mostly the same, we combine them into one material. Since we combined the textures for the clothes, jeans, shirt, and shoes, we also combined their materials into one. Load the consolidated textures into the roughness and normal texture nodes. Set the material assignments to be the same, and delete the others. Now that the model is complete, we proceed with the VRM settings. Open the VRM tool panel and first press the Check VRM Model button. If there are issues with the model, a message will be displayed. If there are issues, correct them. There are polygon errors, but they will be corrected upon export, so we proceed. We set the configurations sequentially from the top of the VRM tool. Check Export Only Selections. Set the VRM format to 0. When you open VRM Meta, there are fields to input information such as the thumbnail and name, so we fill them in. Depending on the VTuber software you use, some settings like rights information might be necessary for it to work, so configure them according to the software. First, we create an image for the thumbnail. We will set up a camera, render the image, and use that as the thumbnail image. Set the output format to 512 by 512 and render it. Save the image and load it in the image editor. Set that image as the thumbnail. We write in the character information. Write the character's name in the title. For the version, use an arbitrary, easy-to-understand number. Enter the creator's name in the author field. Specify the users who can use the character in Allowed User. For now, we set it to everyone. Please search online for other detailed explanations. Next, we perform the humoid settings. We set up the armature bones. Since we use the VRM armature, the bone names match. If they are different, configure them. VRM needs to be exported in the T-pose. Therefore, change the T-pose field from rest pose to current pose. Then select the armature and put it in a T-pose in pose mode. Next, we set up the blend shapes. Open Blend Shape and set the blend shapes for the expressions configured in the box. Press the plus sign next to Bind. Select the mesh and specify the shape key. If there are multiple meshes, configure them all. You can check the expression by moving the preview value. Set up all expressions this way. Next, we perform the first-person settings. Configure them if necessary. Then we set up the spring bones. We configure the physics items such as the hair and chest. Making the hair softly sway when the body moves makes the character look more lively. It's a bit complicated but important, so let's set it up. First, press the plus sign next to spring bone group to add a group. In the Bones field below, press plus, select the bone, and add it. First add the root bone, and then add all the bones connected to it. To prevent swaying objects from clipping through the body, you can set up collision. Below that, in the Collider Group section, add a group. Select the bone to which the collision will be parented. When you press plus under colliders below that and add it, a sphere appears on the bone. Set the size using the numerical value next to it. Select the sphere and move it to the appropriate position. Once the collider settings are finished, press plus in the collider group of the spring bone group above and set the created collider group. Next, we perform the spring settings. Stiffness is the hardness of the spring. A larger value means less sway. The guideline for hair is 0.3 to 0.7. For now, we set it to 0.5. Drag force is air resistance. The guideline for hair is 0.4 to 0.8. Gravity power is the degree of influence of gravity. The guideline for hair is 0.3 to 0.6. If you want to maintain the hairstyle as much as possible, you can set it to 0. For gravity direction, set the z-axis to -1. Hit radius is the radius for collision detection. Set the value according to the thickness of the hair. We apply the spring bone settings to other bones that we want to sway in this manner. Since immediate preview is not possible in Blender, you need to export the model and adjust the settings while testing it in software. It's a good idea to start by entering reference values and then adjusting them during the export process. Once everything is entered, you can export it in VRM format. If the character is realistic, You can export it as VRM as is, and it will work in VRM-compatible software. You can also convert it to an anime-style toon shader. We want the clothing of this character to be realistic, and the face and hair to be anime style. First, select the body model and select the body material. Lower down in the material properties, there is a VRM material section. If you want to use a toon shader, check Enable VRM MToon material. This converts the shader. Now let's configure the MToon settings. First, since the shadow is white, we set a natural shadow color. Lower down, there is an outline section for adding an outline. So set it to world coordinate. Then enter a numerical value next to it to set the thickness of the outline. You can also change the color of the outline, so set it to a deep skin color. Next, convert the face shader to MToon. Set the shadow color similarly. Set the outline similarly. However, the outline is appearing in places like the eyes and eyebrows where we don't want it. You can apply a mask to areas where you don't want the outline to appear. Create a new white image. Name it Outline Mask. Set this as the outline image. Then move to Texture Paint and set the image to Outline Mask. Paint black on the parts where you don't want the outline to appear, such as the eyes. After roughly painting in the 3D view, continue painting in the 2D view. Don't forget to save. This completes setting the mask for areas where we don't want the outline to appear. Next, convert the hair to MToon as well. Set the color and shadow similarly. Since the hair tips are transparent using alpha, set the alpha mode to cutout. The thin hairs have disappeared, so we correct the UVs. This completes all the settings. Now select the model and perform the VRM export. Select the model to be output from the hierarchy and select VRM from the File menu, Export. Name the file and output the VRM. A warning appeared, so we will make corrections. Check the VRM again and fix the problems. Export the VRM again. Once the file is output, the VRM is complete. Let's try running it in VSeeFace. Launch the VSeeFace app. Press Add Avatar and select the exported VRM format file. Information is displayed on the side screen, so press Start. When you show your face with a webcam and it is recognized, the character starts moving along with your movements. The hair is also moving smoothly. If you blink, the avatar also blinks. It reads your facial expressions and changes them to the expressions you created. This character, which is a mix of anime and realistic styles, turned out to be quite interesting. You can also input your voice via a microphone for lip syncing.
Hello! Nice to meet you. I'm a virtual VTuber girl. Nice to meet you.
Once you get used to it, you should be able to perform with natural expressions. Let's try moving it in other apps. We will try running it in 310A Free. Since you can apply motion capture movements, you can check the full body movement. Even with the same VRM file, the appearance changes depending on the app, so it is recommended to try various ones. To move the hands in VSeeFace, you need equipment that captures hand movements called leap motion. However, leap motion has been discontinued, so the only way to get it is secondhand. Therefore, I want to show you a method called VMC that allows you to capture even the hands using just one webcam. First, install software that splits the webcam video stream. We install SplitCam, which is very light and stable. Next, download the VRig Unity software from GitHub. I will put the link in the description, so download the necessary files from the link. Launch SplitCam and VRig Unity and select SplitCam Virtual Camera as the camera source in the settings menu. At the top left, set the resolution according to your camera. Then press Start Camera below, and the character starts moving according to the camera. The hands should also move. When you press Start Sender VMC on the top right, you can send the movement to VSeeFace using VSeeFace. Launch VSeeFace, set the camera to SplitCam Virtual Camera, and start. Press Settings and display General Settings. Scroll down and you will find the VMC receiver section, so check it. Set the port number below to 3333. Then check Apply VSeeFace Tracking below that. Also check Apply Expressions and Track Face Features. With this, body movements use VR Unity and facial expressions use the features of VSeeFace. Since all of this can be used for free, why not try it out? How was it? With this method, I believe you can easily create a VRM character out of any character. Now you can become a VTuber with your original character. Having a cute character adds flair, doesn't it? Now, let's head to the infinite world of creation.
Oh, I'm happy that I can move now, but my dream is to become a galactic patrol member and fly around space, says the character. The world of creation is infinite, right? So please make me a galactic patrol uniform.
Got it. Next time, I want to create exciting videos such as making characters and backgrounds and creating adventure stories. Come on, let's jump into the infinite world of creation.